we continue actually a series of talks from VIRAC. So the next speaker will be Dmitrijs Bezrukovs, also so staff member at VIRAC. So Dmitry, please share your screen.
Dear colleagues, let me introduce myself. I am Dmitrijs Bezrukovs. I am leading researcher in the Ventspils International Radio Astronomy Center, and one of my activities in the center is the implementation of microwave solar observation with radio telescope RT32. So I have a lot to speak about, but we have no time, and I'll try to tell you about some technical, methodological data processing issues, to tell you why we have to separate two individual instruments for sun, and I'll try to speak a bit about the history of our observations, and try to speak about the problems which we expect to solve using our solar observations now. So, first of all, I want to say why is microwave observations of the sun? From my point of view, the best advantage, the main point of the microwave observation is the unique possibility to measure, the possibility for direct measurement of plasma parameters and magnetic fields in the upper chromosphere and the lower corona. It is not simulation, it is not calculation, it is not estimation or evaluation, it is direct measurement by well-known methods. So, and to illustrate this point, do you hear me? Oh.
Yes, we can hear you well. Yeah, please continue.
Of course, I have no feedback. To illustrate this point, I show you this known simulation of active region, and you can see that the G-resonance levels for different for different wavelengths is located as caps one above another. And the idea is obvious. If we could observe the spectra of microwave emission, we could estimate or reveal the vertical structure of active region. And I suppose it is the most interesting and the most significant and most interesting for us. So if we are so the idea is obvious, but this idea had been realized maybe 10 years ago, 15 years ago, begin to be realized. And if we will try to evaluate amount of solar information we could observe with different instruments. So you can see it's a time and wavelength chart. So time when different instruments could observe the sun, and the wavelengths which the instrument could observe. We can see that VIRAC has now his maybe small but honest place. We have the first. Historically, the first observations were made in full-scale I mean, full scale. The first solar observation were made from the very beginning of the from the center foundation. Full-scale spectral polarimetric observation of the sun were made in 2013, 2014 by means of, you can see this front end. We call it a spectral polarimeter version 3 and a abbreviation SP3. It has the frequency range from 6.3 to 9.4 gigahertz. It has 16 frequency channels. It has both possibility to receive both polarizations, and it is used. You can say how it looks. The front end, it uses a wideband feed. There is a spiral antenna under this cover, and you can see how it installed on the radio telescope. You can see, and you can see the radio telescope itself. This spectral polarimeter itself, the device, is integrated in the whole system. Let's say the system solar spectral polarimeter version 3. It consists of it's integrated the system, or it consists of spectral polarimeter itself, control unit of spectral polarimeter, computer that have the software that for data acquisition, storage, and processing. It is integrated to the antenna control system and the system of precise time. So this system is able almost automatically, observe, makes routine observations of sun. It means that the scanning happens, data is going down, and then the data are stored in the 3-level archives. The very low level is all raw observational data, and then another level is semi-processed data, and the last level is end of the session. We can obtain the set of 16 two-dimensional maps of the sun, of course, with the spatial resolution which we have. You can see how it looks. It's Stokes E and V parameters map of antenna temperatures or brightness temperatures. There is a lot of software for data processing had been developed, data construction, map construction, map cleaning. We took a lot of effort for map cleaning, and now it is, let's say, it is working. So, and answering to Valerie's question, what's the data policy we have? No, actually, we have no policy. This data is in open access. Of course, you can use it. So we had a lot of test observations of the sun with this spectral polarimeter version 3. As one of example, I want to show you the interesting place. It is changing of very classic changing of inversion of polarization of active region when active region is approaching the solar limb for one wavelength and for another wavelength. We had for 2 years, we had a number of routine observation in 2019 and 2020, routine observation of quiet sun, just to store statistics of sun, quiet sun, so and for calibrations, for understanding of sorry, for understanding of the meaning of quiet sun. The radio quiet sun is something undefined meaning. So and mainly the experience we got using the spectropolarimeter version 3 shows that it is good device.
Dmitry, sorry, you have 2 minutes left.
Sorry. We had we are trying to change it to another one, so-called LNSP, low noise spectropolarimeter, that is mainly expected for observation of areas of low contrast areas in microwaves, which mainly is associated with the open magnetic fields. So you can see here, you can see the comparison of 2 spectropolarimeters parameters. New spectropolarimeters have extended frequency range. It has less frequency channels, but it has the better signal noise ratio, better dynamic range. It has internal noise generator, precise internal generator. It has internal thermal stabilization, and this spectropolarimeter is able to observe the very low the areas of low contrast and areas that have the reduced brightness temperatures relatively to quiet sun. So time. So as an example, the test observations we made is records of transit of sun with new spectropolarimeter for 1 day and another day. And here you can see how looks the constructed solar map for one and another frequency range, wavelength range, and one and another using the spiral scanning of the disk of the sun. Sorry, so it is maybe it is not significant. So, and the main conclusion from my presentation is that today VIRAC has all possibilities to implement microwave spectropolarimetric observations to the sun. So, thank
you. Wonderful. Thank you, Dmitry. I'm afraid so we have only one, time for only one quick question. So a comment maybe. Does anyone want to say something? Yes, Ivan, please. Go ahead.
Just a small question. Did you had the chance to observe some dynamical event on the sun, such as a CME, like a moving type phoburst or something like that, or just some quasi-stationary situations?
No, we are observing quasi-stationary, and we had no task to observe dynamic, some dynamic characteristic. But it's possible. Why not?
Okay, I understand. Your target right now is mainly quasi-stationary, but it's possible to observe. Okay, yeah, thank you.
Yes, you can imagine the sampling rate about for one and for another spectropolarimeter is about at least for one it is about 50 samples per second, and for another 10 samples per second for all frequency ranges. for both polarization and for all frequency ranges.
Yes, I saw. I think you can do it well. Yeah, can observe dynamic events. Yeah.
No, actually, to be honest, we didn't.
Okay.
Mhm.
Okay.
All right, thank you.